Welcome to section 6.4, vectors and dot products. At the end of this lesson, I will be able to, 1, find the dot product of two vectors, and 2, find angles between two vectors using the dot product. So, let's get started with defining a dot product, shall we? Let's define a dot product. If u is x sub u, y sub u, and v is x sub v, y sub v, and they are vectors, then the dot product. So I got there I go again, moving stuff, and I don't want to move it. I got u, the vector u, and I show dot product. So this is dot product is a dot. I'm just going to make my dot nice and fat. U dot V. Okay, this equals, here's a dot product, x sub u times y. Oh, I'm sorry. No, not y. Times x sub v plus y sub u times y sub v. That is the definition of a dot product. Let's take a look at that in an example. So let us find the dot products of a couple of vectors. I have here two vectors. I have them in component form. The first vector is 4, 5, and the second vector is 2, 3. And I am asking you to find the dot product of this. So the dot product of these two vectors quite simply is 4 times 2 plus 5 times 3. And we do this multiplication just like we would have had we been in 5th grade. So 4 times 2 is 8, plus 5 times 3 is 15. Notice I am observing all the order of operation rules that I am very familiar with. And then 8 plus 15 is 23. Now, let's go to the problem. That problem has 2, negative 1, dot product with 1, 2. So let's do that. The dot product of this one equals 2 times 1. So the x of the first vector times the x of the second vector plus negative 1 times 2. And it's the y of the second vector the y of the first vector times the y of the second vector. Again, order of operations. I do the multiplication of both multiplications before I add them together. So 2 times 1 is 2. And I'm adding that to negative 1 times 2, which is negative 2. And that has a dot product of 0. Last example. I have 0, 3 dot product with 4, negative 2. Pardon my penmanship, that is a negative 2. So the dot product is 0 times 4 plus 3 times negative 2. So I have 0 times 4, which is 0, plus 3 times negative 2, which is negative 6, and I get negative 6 as my dot product. Now, the one thing you should notice right now is that even though I'm doing the dot product of two vectors, when I do the dot product of these vectors, I get a scalar number back. Remember, vectors have magnitude and direction. Scalars have only magnitude. Very important.